Hello? Yes, this is the CEO. You're dropping us as a company? We're gonna go bankrupt. You can't just drop us. Yes, I know the competitors have more sales, but we have better quality water than them. You can't just drop us. You don't care? They're still gonna make more money than us, so you're just gonna drop us like that. Okay, bye. I told my employees. Oh my gosh, this is really bad. Hello? Yes? You're calling from Mars. How are you? What do you need help with? You need water for your companies. What companies are you needing water for? You have an amusement parks and a modeling agency? And you don't have any water from Earth left. I see. Okay. When do you need this by? Like soon, like next week? Oh my gosh. Okay, yeah, come down. We can maybe have a meeting at our office like the beginning of next week. Does that work? Okay, sounds good. Hi, welcome.
Hello.
Hi, my name is Lanny O'Hara. I'm the CEO of AquaStellar, and in the workplace, I will be encouraging my teammates to work together and ensuring the vision of our project to be seen through. And for our mission to Mars, I'll be leading the experimentation of water and ensuring your companies have proper trust in our company to give you guys clean water. Let's start the tour and meet the employees. So this is our first employee, Kai Verma.
Nice to meet you. I'm Kai Verma. I'm the quality assurance manager here at AquaStellar. So, as quality assurance manager, in real life, I implement and develop various quality control checks and to meet the standards and satisfaction of the consumers, ensuring the safety. That's my #1 priority. Here in the classroom, I make sure all the assignments get submitted on time with strict deadline and make sure they adhere to the rubrics criteria. On Mars, I'm gonna oversee the various water processes from melting all the way to purification and filtration, making sure it's safe and that there are no hazardous chemicals or anything that would contaminate the safety of our customers. And I do this by cross-sampling the water from Mars and Earth to make sure it meets the safety standards.
Thank you. All right, this is our next employee, Kevin.
Nice to meet you. Nice to meet you. Nice to meet you. I'm the media manager, and I'm in charge of handling all the media, files, videos, and also advertisements, you know, that kind of stuff. And I've been developing this bottle. It's a biodegradable bottle. It's made out of materials that's durable enough to when you drink it. This very durable material. It's biodegradable. See this? I manage this, and it's top of the notch, top quality. And this is gonna sell great. We might even sell it on Earth. And we're gonna make a lot of money there. It's Mars water.
Thank you. All right, so this is our next employee. His name is Sydney Ray.
Nice to meet you.
Nice to meet you. Nice to meet you. So as the CTO or Chief Technology Officer here at AquaStellar, I'll help manage the technological strategy and direction of our company. Here on Earth, I will help create and design sensors that will be used on our devices to help extract the water from the ice caps on Mars and deliver it to your consumers. On Mars, my job would be a little bit more advanced and complex. I'd be helping create rovers and drones and AI that will help manage all of them to help extract the water.
Thank you. All right, this is our next employee, Jackson.
Hi, I am the field support specialist, and my job is basically to make sure everything runs as smoothly as possible. So I'll be doing that on Mars by running around to each place, making sure the rover's properly working, making sure everything's going correctly. In the classroom, I'll be prompting the timeline and making sure that if somebody needs help, I'm there to help them and get through it. Yeah.
All right, thank you. All right, this is our final employee, Theo.
Nice to meet you. My name's Theodore Howe. I am the mechanical engineer here at AquaStellar. My job on Earth is to make sure all the systems and water purification plants are running smoothly and don't break. And here in the classroom, I will CAD model all the systems and make sure that they're all modeled out so we know how to make it on Mars. And then on Mars, I'll be making the plants. It'll be slightly more difficult because I'll have to suit the terrain and a new atmosphere on Mars. So I'll have to adjust my plants and purification processes for Mars. And for you guys, I'll be making sure you get all your water on time and all of the systems are running well so you have a constant flow.
All right, thank you. All right, thank you guys for coming in.
Yeah, of course.
Nice meeting you.
Nice meeting you. All right, I'll show you the door. Okay guys, so we kind of just promised them we were gonna give them clean water, but we have no plan on how to do that. So does anybody have any ideas?
I have
Theo?
an idea.
You have an
This is
idea?
my plan.
Okay.
I say, on Mars, there's like poles, right?
Yeah.
This is my little diagram. We have ice up here and ice below here. I say if we like extract the ice from Mars and melt it, we can give a constant flow of water and make sure everyone has water. We can use it with rovers. We can make sure rovers can transport ice to our plants and we can melt it at the plant and make sure that we
That's a
have
solid
enough water.
idea. But what are we gonna put on the rovers to make sure that they're gonna work and like be able to actually get the water? Because rovers, they can only like go so far by themselves, but they have to have components on them to be able to test the things about Mars, right? So does anybody have any ideas about like things we could put on it?
I have an idea. We can equip the rover with a temperature sensor. We will have to do this because we need to map out the temperature of Mars. Mars is an extremely cold environment, so we'll have to map out where the ice is by detecting the temperature of the poles. We'll also need to, at the plants, we're gonna have to keep the temperature at an ideal level. That way our ice doesn't accidentally refreeze. And we will do this by attaching the sensor to the rover. We will have it store the data and display the data so we can keep track of everything. We could possibly use a resistance temperature sensor for surface temperature, an IR sensor for temperature readings from a distance, and we can use a thermocouple sensor for our device to make sure that it stays at ideal temperature, and waterproof digital sensor to make sure our water stays at non-melting temperature.
Perfect. Any other sensor ideas? Because we're gonna need more than just temperature. Guy, do you have an idea?
Yeah, besides the temperature sensor, I also came up with an idea to add a pressure sensor. So we would equip the rovers or even drones later on with the pressure sensor, send them out to the polar ice cap's desired location, and that would take the pressure of the environment there. It would log it back to a computer, and then we would keep records. We need this to analyze the data to make sure that it's a constant pressure so we can extract the most amount of water and turn our profits high. We can do this by having like an all-out pressure sensor that can withstand the pressure at that location, making sure all our data gets back to us so we can use that to further our company.
Okay. Any other ideas?
I was thinking about a distance sensor. This is important because getting the ice back and forth, if we use something like a camera, then you'd have to use AI and that could get complicated. As for a distance sensor, like a GPS system and like an actual distance sensor, this would allow us to automate it more. So like maybe it sees a rock and it could just kind of avoid it. As opposed to if it used a camera and a neural network, that'd get expensive and complicated. And that's a point of failure, so distance sensor is a good idea.
It's a great idea. Jackson, do you have any input?
We forgot the most important one. We need a moisture sensor if we're going to be in the water business. We'll put it on the rover, and we can find high concentrations of water when measuring the amount of moisture in the soil. So we can find higher locations, then we can send all the rovers there to extract and melt and bring them back to our factory.
Sounds great. All right. Got to get to work then.